Hello everyone, welcome to AI Anytime channel. So in this video, we are going to have a look at newly released text-to-speech model called Bark. So I came across Bark on Reddit and let me read you the headline. It says Bark text-to-speech but with your custom voice cloning using on audio and text samples. And they have released this model, text-to-speech model, which is completely open source at this moment. Okay, you can also use it commercially, but if you want to use it on a large scale, you do need the licensing from their they have given the link. I think they are using an encoding from Facebook, but this is available as a commercial used open source model. Okay, so they also have given a description. Now you can clone audio using just 5 to 10 second samples of audio and text pairs. So remember, we had seen Wall-E by Microsoft. When it was came in the news that it can clone your voice in less than 2 seconds, right, of the audio sample. And now Bark coming in again, which has been inspired by the Wall-E as well. You can read that in this GitHub repository that I'm going to show you in a bit. And we'll also try to unlock Bark, that why Bark might be better, what kind of technique they are using in their architecture that they have trained the model on. How is it different from the traditional or old speech synthesis model? How Bark is different? Okay, I will try to cover that as much as possible in this video, and it's completely open source. As I said, you can run it as well locally. You can set it up. It runs on CPU as well, surprisingly, but the inference time is too long. Okay, if you have around a single line prompt, you want to generate an audio, it might take up to 30 minutes on a CPU machine. But if you have a GPU machine, you can inference it faster. Now, this can be the Apple moment, when it comes to audio generation, guys, or the voice sample generation. Let me know your thought in the comment box when I cover this. You see, I'm on the GitHub repository. It says Bark by Suno AI. Okay, and they say Bark is a transformer based text to audio model created by Suno, and Bark can generate highly realistic multilingual speeches. So they have multilingual capabilities. When you have a prompt or a text, you want to generate speech, you can use their multilingual capabilities as well. So they provide the languages like Hindi, German, French, for example. And they do include music, background and noise and different audio effects. Now, if you see old or traditional speech synthesis model or text-to-speech model, for example, Toto, HTTS or any other, they struggle with, putting this noise or music. Now, if I want to generate a speech where it contains laughter there. So, old and traditional speech synthesis model kind of struggled with those audio effects, but Bark is claiming that they can do that, and we'll see their results as well. And they have given a Colab notebook that will try to inference with some of the sample prompts. If you come down, you'll see they have given some samples, some code inference documentation, etc. is available here that you can have a look. It runs on hardware and inference speed, similar to Wall-E and some other amazing work in the field. Bark uses GPT style models. Okay, generative pre-trained transformer. You have been seeing a lot of GPT's model nowadays. So GPT styles models to generate audio from scratch. What they are doing different here, guys, it's very interesting. I will explain that, very intuitive. Okay, I don't want to just read the documentation. Anyone can go on their GitHub repository and read it. What I want to do I want to help you understand that how are they different a bit than the model which has been released in past. Let's head back to my tab here, guys. So I'll just explain. If you read this, one of the lines here, it says, different from Wall-E, the initial text prompt is embedded into high-level semantic tokens without the use of phonemes. Now, very interesting. What is this phoneme, guys? This is very interesting to even understand this. This is very intuitive. So let me just explain that what this line means. That Wall-E might have been using phonemes or any other traditional speech synthesis model, for example, Toto, HTTS, etc. They might have their own architecture or techniques when they train this model. Now, if you see, they have some non-speech sound that I was saying, laughter, laughs, the music, clear throats, and all those audio effects are also included. If you read this, let me explain this. If you come back here, we are talking about something called phonemes. Now, what do we mean by phonemes? Okay, so phonemes are nothing but, let me write it over here. It's nothing but, it's represented using the symbols of the IPA. So there is something called something called IPA, which is International Phonetic Alphabet. International Phonetic Alphabet. And they have some symbols. So these IPA symbols that you see are used by the one who works with speech sounds. So if you are working with speech sounds, mostly you will come across phonemes. Okay, now let's take a simple example. I'm just taking this cat word. Now this is my word cat. Now how does I represent this in phonemes? Okay, so if you see cat, it's nothing but it consists of 3 phonemes. So this is how we write. For this cat that you see, this is how we write, and that's how we generate the sequence. We read this in a sequence, then it generates an audio waveform, and that's how it gets generated. So you see, this is a way of writing. So we have cat, and this is the consist of 3 phonemes. So these are 3 phonemes here. I'm writing it P1, P2, P3, for example. Now we first learn. So if you want to pronunciate these phonemes, or if you want to create an audio, you first learn the sounds associated with each IPA symbol. So there are symbols in IPA that you see. I'm using 3 phonemes here. These are all symbols. Okay, and then produce sounds in sequence. Sounds in sequence. Now, what are the limitations with phonemes? Why should we not use phonemes when we are trying to generate audio from a prompt, or a text prompt rather? If you come over here, it says different from Wally, the initial text prompt is embedded. So the text prompt that user is making, or while the training as well, is embedded into high level semantic tokens. I will come to that terminology. What do we mean by high level semantic tokens without the use of phonemes? Okay, now let's come back to our this discussion of phonemes here, guys. So if you see, let me just take this. There are 2 major limitations. The first limitation, which is the major one, that phonemes symbols, or the phonemes that you see, are specific to language. Okay, so they are specific. So they are specific to language. Different language may have different set of phonemes. Okay, so if you have English, it will have I'm just writing is SP1, which is set of phonemes. Now you have French, it will have SPF, for example, let's call it SPN. And then you have German, then it will have SPGR, for example. So different languages, different set of phonemes. It might have different set of phonemes. So it's not easily generalized. Okay, so it cannot generalize to the task, because if you talk about Bach, it claims that it provides different languages. If you come over here, you see these are the languages, supported languages, from English to Chinese, and they are Chinese is the language, or do we call it Mandarin? I don't know. So English to Chinese, and then Arabic, Bengali, Telugu, the Indian regional languages are also coming in, and Arabic is also coming in, very soon. So they support multiple languages. But when you talk about phonemes now, as is specific to languages, most of the time they have different set of phonemes for different languages. They are not easy to generalize to the task involved multilingual capabilities. Okay, so not good for multilingual task. That's the biggest limitations of phoneme. The second limitation that comes in, guys, is doesn't capture the full meaning of the text. Okay, so it doesn't capture the full meaning of text. So the prompt that you are making, right? So if you are going ahead with phonemes based architecture, okay, sometimes it doesn't understand the context of that meaning. So that's why we can see it over here on their GitHub repository. They say that they are embedding into high level semantic tokens. Now let's understand high level semantic tokens. What they mean by this? Okay, high level semantic token. So now we'll see about Bach. I really like the name, guys, Bach. So it's barking something, right? So text to speech. So it says Bach uses high-level semantic tokens instead of phonemes, to represent the meaning of the input. Okay. So the first thing, let's have this. Okay, a prompt. Now, if you want to generate an audio of a dog barks loudly, for example, a dog barks loudly. I hope this is readable. I hope you can read this. Yes, a dog barks loudly. Now, what do you mean by semantic token, or that to a high level semantic token? Okay. Now let me help you understand. Okay. So the major concepts here are these three concepts. The first concept, I'm writing it concept one. My concept one is nothing but the dog. Now we have concept two. Concept 2 nothing means barking, right? It barks, so it asking to bark. So, and concept 3 is something like loud. Now there are these three major concept behind this text prompt. Okay, so what it does, it tries to capture the essence of the word. Okay, the context or essence of the sentence or the word behind it, essence of the word. I'm just writing it prompt, context or essence of the prompt. Okay, so this is how it create the embeddings for these different concepts, and then what it does, your encoder and decoder network comes in the picture. Okay, so encoder plus decoder network comes in, and then you use these embeddings etc. with their corresponding audio waveforms to train the model, and then you kind of generate this audios based on the prompt. And this is interesting. This can work for multilingual. It's generalized better as well when you are comparing this with phonemes based architecture. And that's why BARC BARC is using this high level semantic token based techniques rather than going with the phonemes there. Okay, it's more flexible and versatile for a wide range of tasks. Okay, this high level semantic token based technique. Okay, so that's a very high level understanding of the phonemes versus high level semantic tokens that you see. Maybe I can give the snapshot of this in the description through a drive link or something. Okay, and now what I will do now, okay, let me just go back to this BARC. This is the GitHub repository. I will give the link in the description. Now what I will do, I will just use their notebook. They have given this notebook, okay, to inference the model. Now as you can already see, if you go to the runtime, you need GPU to run this. Okay, I'm not going to restart runtime. So change runtime type. In change runtime time, I just doing it save. Let's run this. Authored by Google, run anyway. This is what I'm going to do. Meanwhile, it's getting installed. Let's head back to their samples here, guys. So you can see they have samples here, speech synthesis. They have generated some audio for you. Let's hear that audio, the qualities, etc. here.
The model is called BARC, like Clifford the Big Red Dog, or bark as in tree bark.
Did you hear that? Or right? It's like very natural. Okay, when you generate this. Let's see if we can get some laughter examples. They do have some laughter example that I like to show you, so you can hear it. You see this? They have added this in the prompt, laugh. Okay, and now if you hear this, you will understand what I'm talking about.
And hello, my name is Suno, and I like pizza. But
did you hear that laughter there, guys? That's an audio effect. It makes you like, okay, you are listening to an audio, for example, and it gives you the vibe that okay, this is a very natural one, that you are rather than the old speech synthesis model, which is very difficult to customize with this settings, okay, like preset, etc. Like you need fast, you need slow. A little difficult. I'm not saying it was not possible. Of course it was. No, but this is amazing at the first look, and that too an open source model that you can completely run it locally, even on a CPU machine. But though it takes time, but you can run it on a GPU on a good 4 to 8 GB GPU. You can. I think the VRAM which is required for this is I think 10 GB. As a standard requirement for this model. I read it on Reddit. And if you come back, you can see it's installing. It needs some specific versions of PyTorch, etc. You can see it's installing it over here. And once it needs PyTorch nightly and all those things. Once it installed, we'll also run this we'll import the Bark dependencies and modules here. If we load preload models and then the text prompt, I'll change the text prompt by the way. Okay, so let's change the text prompt. Hello, I am testing model for text to speech that's called Bark. And what I will do here, I will write clear throat, but I also have other interest. No, I will not use this, but I also have constraints like running it locally, something like this. Okay, and then we'll generate this sample. They have also an advanced sample here with different languages. You see this text prompt is a different languages. Maybe you can take a different language and see if it's able to generate. And they also have speaker based, multi-speaker. So you have man, you have women in that. You can also create that, separately in audio. And they also have history prompt. So you have some history prompt. You can learn from the speaker 1, speaker 2, etc. and then it will generate on top of that. Let's see that if you got our first thing. So it has said it has installed it, guys. So what I will do now, let's run this. So when you are loading the models, sometimes it takes a little time on even on Colab, because they will download the model checkpoints and weights, which is around 5 GB plus. So let's see that. And what I will do, I will give this link in the description, guys, that you see Bark examples. AI is they're using Notion for the documentation and all. So all these languages, they have Hindi as well, which is very interesting. I will test it out, and I also give you this link in the description so you can try. And also I also give you this some screen grab of that so you can read it. So let me come back once this is done, guys. It will take little time. So I will pause the video here and I will come back once this gets complete. So you can see this is completed. It took little time, to download the model checkpoints. It will get stored in the local cache directory, guys. Okay, now this is my text prompt. What it does, it has a variable. What it will do, it will create an array of this audio array, generate audio text prompt, taking the text prompt as an input, passing to this generate underscore audio method that we have imported from Bark, and then we are passing this as a rate equal to sample rate, which might be default. I don't know how that is. Let's see. So first let's run this. Might be 22,000 hertz or something. We have to figure it out. Okay, so what it does, you can see some steps are, these are the steps. Okay, so it says 20 out, 21, 22 steps out of 100. So it has 100 steps. These are, you might have already seen with different auto-regressive model. Okay, if you have used Auto HTTS, for example, or any other text-to-speech model in past, you might have seen these steps, and also with diffuser model as well. Okay, so, and this is on a GPU machine. You can run the same model on CPU, but it will take an hour or something, 30 minutes to 1 hour, for this kind of prompt to generate the audio. Okay, at least it works. Okay, with a decent RAM of 16 GB and some I don't know, I think 60 to 100 GB of memory space. Okay, that it takes on a CPU machine. On a GPU, I think what I read on Reddit is that 10 GB of virtual RAM is required, to run this with a fast inference speed. Okay, you can see this is a decent one, and provide Tesla T4. Okay, here on Colab GPU. So you can see 78% to 80% have been completed. Let's hear some other examples as well, guys. I'm very much interested in this speaker prompts.
I would like an oat latte, please.
Wow, that's expensive. Wow, that's expensive.
So you can see there are two different speakers, and it has generated in the same audio, which is very interesting. It helps it really helps you when you also to generate a lot of samples data, for your contact center, or if you have contact or call center, right, in the organization. It will help you create, this is a very interesting idea and use case as well, where you generate this, conversation for training modules. You are creating some training modules for your employees, the new joinings or the new employees. They can go through those simulated training modules which has been generated by Bard, for example. You can generate these voices here, okay, the women, man, and you can create an audio, you can have a script, you can pass it to this, and you can simulate this. But you need a GPU machine to do that, guys. You can see 34, and this thing that you are seeing, right, it totally depends on the length of your prompt. If your prompt length is lengthier, it will take more steps and more time, of course, to generate that. So let's see. Let's hear to some other as well. Voice preset and voice cloning. As I was saying, right, you can also clone voice. So you have to pass it here in history prompt. Now you have your own voice, or you want to, for example, clone Elon Musk or Sam Altman's voice. How you can do that? So you can also use this to do that.
I have a silky smooth voice, and today I will tell you about the exercise regimen of the common sloth.
Cool. So we saw speaker prompts, we saw this. Let's hear the music, guys. So they also claim that
In
they're
the jungle, the mighty
creating this as
jungle,
well.
the lion barks tonight.
This is amazing, right? It says Bard can generate all types of audio and in principle doesn't see a difference between speech and music. Sometimes Bard chooses to generate text as music, but you can help it out by adding music notes around your lyrics, right? You can see this, if you see it clearly, they have this
In the
here over
jungle,
here.
the mighty.
And I really like the response. Just imagine if you want to create a deep fake of it. So you have a video, you use any deep fake video of, you have a lot of GANs model there where you can create a fake video, a fake face, and you use this to simulate that, right? A music completely, you can create a singer out there, okay, completely a voice. You can pass that history prompt, Ian speaker one here, and then you pass this musical notes around your lyrics, and you create Rihanna's voice, or for example, or for some other voice, Justin Bieber's voice, and you use their deepfake video and create an music video there and launch it on social media. It gets viral, and you see it's around 54% completed. Take little few more time. So the foreign languages.
Buenos
let's hear
días,
that as
Miguel.
Buenos días.
Tu colega piensa que tu alemán es extremadamente malo. But I suppose your English isn't terrible.
Oh, wow. So it says Bard supports various languages out of the box and automatically determines language from input text. This is fantastic. So we are not passing an extra parameter or additional layer of parameter there which kind of you specify the language in that function. It automatically determines language from input text. Okay, and that's how we were discussing earlier, right? Phonemes versus high level semantic tokens. These are the reasons that phonemes might not help in this kind of task. And this is so intuitive, guys, to understand. I'm really loving it. Maybe I will create an application very soon on this top of that. Or let me do like this. Okay, I'll create an entire deep fake music video. Okay, in one of the upcoming videos on my YouTube channel. Okay, combining Bard, combining Midjourney, combining some GAN models, and we'll create this amazing deep fake music video that you will see soon. You can see it's 74% completed, and it's very high level, guys. For example, when I say high level, they're providing you these high level APIs. Okay, so you don't have to write a lot of codes there. So they have created all these classes and modules for you. Just import that module and you pass your prompt and generate the audio. But the thing is, you should understand the fundamentals and the basics behind it, how it's working, what is phonemes, for example, and what is semantic tokens, for example, how encoder decoder network works. You want to understand more about it, please watch my previous videos. I have covered in most of my videos from fundamentally how these things works. Okay, so it says 82%, 85%. See, on a free GPU by Colab T4 GPU, it's still taking around 6 to 8 minutes. So inference speed is very terrible, guys, but it expected. These are compute heavy and compute hunger models, and they will take time. As I said, you need 10 GB of VRAM to run it smoothly. Let me know your experience with this model, Bark model, in the comment box. If you have any thoughts, please let me know. If you are extending it further in some kind of application, as I discussed couple of use cases, one for call and contact center, that how you can simulate and create training modules for your new joining or employees, and then you can also have deep fake music video, you can create using this, combining all these techniques and models. Please let me know if you are extending it. It says 97% completed. Let's see. 100% completed. And we finally got our audio, guys. Let's
Hello,
let's hear this
I am
audio.
testing a model for text to speech that's called Bark. But I also have constraints like running it locally.
Wow, this is great. This is so good. Maybe this is fantastic. I don't know if I can print the sample rate. Let me just do one thing. Okay, can I print the sample rate here, guys? 24,000. Okay, this is good. I really liked it. So it's giving good responses, guys. So you can also play with this other here as well. Okay, this will take time, so I'm not covering it. Pretty much self, you are just using their code, okay, and up to documentation. What I wanted to help you understand in this video is about phonemes, high level semantic tokens, and about creating a little bit of this awareness about Bark, because every day nowadays you are seeing an AI model or an AI tool getting released in the community. People are going crazy about it. I hope I'll cover this in one of my videos, and that's what I did. And that's all for today's videos, guys. If you like the content, please thumbs up the like button there, and if you haven't subscribed the channel yet, do subscribe the channel. Please share the video and channel to your friends and to peers. Thank you so much for watching this video, guys. See you in the next video.